Hey there, and welcome. So today we're going to learn the secret language of data. And don't worry, this isn't about complex math. Think of it more like you're becoming a data detective, learning how to find the clues and uncover the stories hidden inside all the numbers that are around us every single day. Let's start the investigation. You know that feeling, right? Like you're just drowning in a sea of numbers. I mean, from news reports and sports stats to medical studies and what the market's doing, data is just absolutely everywhere. It can feel pretty overwhelming, for sure. But what if you had the tools to actually make sense of it all? And that's exactly what we're here to do. See, the real secret isn't about being some kind of math whiz. It's about changing your perspective. It's about learning to look at data with a critical eye, to spot the clues and to piece together the evidence, just like a detective working a case. All right, so every good detective needs a system, a way to organize all their clues. In the world of data, our system is called the data matrix. This is our first and probably our most fundamental tool. It's how we're going to bring some order to this investigation. Now, I know data matrix might sound a little technical, but trust me, it's just a fancy name for a simple grid. You know, like a spreadsheet. This basic structure is the key to organizing any set of data, no matter if it has 10 entries or 10 million. It's how we turn all that chaos into clarity. Okay, let's make this real. Take a look at this example. This is a data matrix showing information for 60 different nations in the World Trade Organization. We're going to use this exact table to break down the three core parts of any data set. First up, we have what are called elements. In this table, each row is one element. These are basically the who or the what of our investigation. So countries like Armenia, Australia, and Austria, each one is an individual element. They're the main subjects in our case file. So if the rows are our subjects, what about the columns? Well, those are our variables. A variable is just a specific characteristic we're interested in for each element. It's the clues we're collecting, right? Things like their WTO status, their per capita GDP, or their Fitch rating. Each column is a different piece of evidence. And finally, when you take one entire row, that's one element with all of its variables measured, you get what we call an observation. The best way to think about it is like a complete case file for a single subject. So all the data we have for Armenia, from its WTO status all the way to its rating, that makes up one single observation. Okay, great. We've organized our evidence, but any good detective knows that not all clues are created equal, right? Some clues are names, some are rankings, and some are really precise measurements. So our next job is to learn how to properly classify all the data we find. In statistics, we do this using 4 different scales of measurement. These are absolutely essential categories for our detective's toolkit. Understanding them is what tells us what we can do with our data, and, just as importantly, what we can't. The simplest scale is called nominal. This is data that's purely for labeling. You're just putting things in buckets. In our dataset, the WTO status is a perfect example. A country is either a member or an observer. There's no ranking here. One isn't mathematically better than the other. They're just names for different categories. Moving up a step, we get to the ordinal scale. Now here, the order definitely matters. Think about those Fitch ratings. We all know that a AAA is better than a BB-. We can rank them. But, and this is a big but, we can't say that the gap between an AA+ and an AA+ is the same as the gap between a BB and a B+. And knowing this is so important because it stops you from making a classic mistake, like trying to calculate an average credit rating, which would be totally meaningless. Now things are getting much more precise with the interval scale. With this kind of data, not only is it ordered, but the space between the values is a fixed, meaningful unit. The classic example? SAT scores. The 70-point jump from a 550 to a 620 is exactly the same as the 70-point jump from a 620 to a 690. And that brings us to the top of the ladder, the ratio scale. This is the most informative of all. It has everything the interval scale has, but with one crucial addition, a true, meaningful 0 point. Things like GDP or weight or price, they're all on the ratio scale. A GDP of 0 means, well, 0 economic output. And that lets us make powerful statements, like this country's GDP is twice as large as that one's. So to make things a little simpler, we can group all 4 of those scales into 2 main types of data. First, you've got categorical data, which is all about labels and categories, using those nominal or ordinal scales. Then you've got quantitative data, which is about numbers, how much or how many, using the interval or ratio scales.
Getting this difference right is absolutely vital because it's what tells you which statistical tools to use for the job. Okay, so we know how to organize our clues, and we know how to classify them. But where do detectives even get their evidence from in the first place? Let's take a look at how data is actually collected out there in the wild.
A data detective really has three main ways of gathering evidence. You can use clues that have already been collected, you can go out and just observe a situation as it happens, or you can actually run a controlled experiment to test out a theory.
By far, the most common way to get data is by using existing sources. This is basically the detective's version of pulling old case files. Businesses do it all the time with their internal sales records, and researchers use these huge databases from places like Bloomberg or government agencies. The data's already out there, just waiting to be analyzed. But what happens if the data you need just doesn't exist yet? Well, you can conduct an observational study. This is like being a detective on a stakeout. You just watch and record what's happening without interfering. A survey is a great example. Or you can run an experiment. This is where you get hands-on. You go into a controlled setting and you intentionally change something to see what effect it has, like a drug company testing different dosages in a clinical trial.
All right, this is it. We have our data, we've organized it, we've classified it. Now it's time for the final, most exciting step, cracking the case. How do we turn all this raw information into a real conclusion or a smart decision?
This really happens in two main ways. First, we have descriptive statistics. This is where we're just summarizing the evidence we have in front of us, calculating an average or creating a bar chart to see it visually. But then we can take it a step further with inferential statistics. This is where we use data from a small sample to make an educated guess or an inference about a much, much larger population. It's exactly how election polling works. This all leads us to the real power of analytics, which is about putting our data to work. It usually starts with descriptive analytics, which uses data to answer the question, what has happened? Then we can move to predictive analytics to try and forecast what will happen. And the ultimate goal is prescriptive analytics, which helps us figure out the best move to make, answering that final crucial question, so what should we do about it? So there you have it. From the data matrix to the scales of measurement, you now have the foundational toolkit of a data detective. You're ready to look at all the numbers and charts you see every day with a brand new, more critical eye. The only question left is, what truths are you going to uncover?